Basically, there are 6 missions of Ocean Decade, which aims transformative ocean science solutions for sustainable development, connecting people and ocean. And I think you'll hear more in the coming talks of our 2 panelists. Thus, it is my utmost hope that we consider how we play a role in supporting efforts to reverse the cycle of decline in ocean health, particularly as we strategically gear ourselves in preparation for the next decade that the United Nations has proclaimed as the decade of ocean science for sustainable development, 2021-2030. Together, we can create improved conditions and management for sustainable development of the ocean and for the being of everyone. I hope all participants will find the webinar enjoyable and discussions stimulating and engaging. For any inquiries, please place your questions to our speakers on the chat box Q&A section at the end of their presentation. And I'm happy now to introduce our first speaker, none other than Professor Minhan Dai, coming all the way virtually from China. Thank you, Prof, for joining us. It's a pleasure to see you again and to have you today with us in our webinar. A brief introduction about Prof Minhan Dai, a good friend of ours in IOES. He's actually the chair professor of marine biochemistry at Xiamen University, China, where he serves as the director of the State Key Laboratory of Marine Environmental Science. His primary research interests are biogeochemistry of carbons and nutrients and geochemistry of radioactive elements in surface and groundwaters. And recently, his research interests have been expanded, thinking ocean science and sustainability. He is a renowned scientist, has published over 200 papers in leading international journals, has led 2 China coastal carbon programs since 2009 in the framework of 973 program sponsored by the Ministry of Science and Technology of China. He's also the leading PI or principal investigator of a newly funded NSFC major program, carbon fixation and export in oligotrophic ocean for 2019 to 2023. He was also elected as an academician of the Chinese Academy of Sciences in 2017. Prof Minhan Dai has served on many national and international committees. He was Secretary General of Asia Oceania Geosciences Societies, AOGS, during 2010 to 2012. He was the president of AOGS from 2009 to 2010, founding president of AOGS Biogeosciences section from 2012 to 2014, and also a member of advisory board of Oceanic Acidification International Coordination Center, OAICC. He's also a member of expert group of high-level panel for sustainable ocean economy and a core group member of special policy studies on ocean governance under China Council for International Cooperation on Environmental and Development, CCI-CED. He was the co-chair program committee of Ocean Ops 19 conference and currently co-chairing the international program Surface Ocean and Low Atmospheric Studies. So there's more to his bio data, but I'm sure you can Google him. He's a renowned scientist from China. And without further ado, I'm now inviting, with pleasure, Prof Minhan Dai to deliver his talk entitled Coastal SOS, Coastal Zones Under Intensifying Human Activities and Changing Climate, a regional program integrating science, management, and society to support ocean sustainability. You have about 40 minutes, Prof Minhan, and we will proceed with Q&A for his session. So if you have any questions, please do type them at the Q&A and we will address them at the end of his talk. Thank you so much and welcome, Prof Minhan. The floor is yours.
Thank you. Thank you very much, Sumiani, for the very comprehensive introduction. And as always, it's a great pleasure of mine to join my colleagues in Malaysia, in particular UM. And I'm also very pleased to learn that Malaysia is launching this national event for this for the UN decade. Now sharing my screen. I hope you see my screen okay?
Yes, it's okay, Prof. All good.
Thank you again. So this is again, it's my great pleasure to share with you actually a project being proposed to the UN decade. and called Coastal SOS. It's coastal and intensify human activities and the changing climate. This is a regional being summit to UN Decade as a regional program. We are trying to integrate science, management, and society to support ocean sustainability. Okay, a little bit slow with the online. So this is kind of the program overview. So we are trying to partner a new partnership across the academia, industry sector, foundation, and intergovernmental, non-governmental organization, and try to co-design the research and on these coastal issues, primarily hypoxia, harmful algal blooms, eutrophication, and oceanification. And through this partnership and the co-design and the co-research, we're trying to deliver this capacity, advanced knowledge in order to solve the societal problems. And I'm showing you here quite a bit of the partnership, including University of Malaya as one of the partner for this proposal. Hopefully we can get endorsed by the UN Decade. Before I get into this program introduction, I just want to step back a little bit and share with you my thoughts about ocean health, and about very brief introduction about the Decade program. And Sumiani actually has introduced it a bit. And then I get into the Coastal SOS program design and a little bit about the perspectives. We all know about ocean, and I think this is 7 literacy about the ocean. The Earth has one big ocean with many features. We all know that. The ocean makes Earth habitable. The ocean is major influence on weather and climate. The ocean and human are closely linked. The ocean and life in the ocean shape the future of the Earth. The ocean supports a great diversity of life and ecosystem. The ocean is largely unexplored. I try to summarize the important role of the ocean in both the economy and the societal development on the left column, and then the ocean as a huge component in the Earth system. We all know the ocean occupies approximately 70% of the Earth's surface. It contains mineral energies, and if you want, it's 90% of the logistic flow actually transport from our oceans. And a lot of people concentrate at the coastline, and it accounts for over 95% habitable space on the planet. And the ocean contains the most of the heat of the Earth. There is more heat stored in the first 20 feet of the ocean than the entire atmosphere. And since the Industrial Revolution, actually, the ocean absorbed more than around 90% of the anthropogenic heat generated by the greenhouse effect. Of course, it's driving the water cycle and making the food, and 50% of the oxygen we breathe actually come from the ocean. Of course, it's absorbed 30% of the atmospheric CO2. That's one of the major fields. So I just give you one example, the ocean's role in uptaking anthropogenic CO2 emission. So we know on the left corner, the source of the anthropogenic CO2s come from both the fossil fuel burning and the land use change. And about accumulatively, the ocean accumulate about 1/4 of the atmospheric CO2 since the Industrial Revolution. So we all know, so the ocean absorbs the heat and carbon, And so we often say the ocean is the actor fighting with the climate change, but at the same time, it's also a victim. The heat uptaken by the atmosphere, by the ocean, actually warm up the ocean, and the carbon uptaken by the ocean is also making the ocean acidification. So this is a kind of the overall view. We know this ocean acidification, a little bit about the more ocean acidification. We often call the CO2 cause the global warming, and also the cause the ocean acidification, we call it another CO2 problem. I'm sure you are all familiar with this ocean acidification issue. It's a broad, diverse impact on the ecosystem, including buffer capacity of the ocean and the eco metabolism, biodiversity, and biogeochemistry as well. And another issue we have been recognized during the last 10 years is the deoxygenation. It's related to ocean warming, and if you go to the coastal ocean, it's related to eutrophication. So we say the ocean is losing its breath or deoxygenation, and mostly people call it as a hypoxia if you're dealing with the coastal ocean. If you want, you can do a very simple calculation. 1 degree of warming of the seawater, you make 2% of oxygen decline. So about 3 years ago, we have this issue, the Kyoto declaration. We call the ocean is losing its breath. And actually the deoxygenation is happening to both the open ocean and the coastal ocean. This change of the ocean chemistry and eventually leading to the health, the ocean health degradation can be measured. For example, this is we can measure the ocean carbon chemistry change along with the atmosphere CO2 rise and the pH decline. And I just want to draw attention, the rate of the increase are very important, both in terms of the atmosphere CO2 and the global temperature, pH. So if you want, during the last 400,000 years, the change is minuscule. But during the last 100, 200 years, it's just the accelerated change, dramatic change is just the put the pressure to the ocean. And the ecosystem, you know, this takes time for adapt to this change. This is a big issue. So I'm just trying to focus my talk today is on the coastal ocean. And you see here, we have the 4 spheres, and in between the intersect of these spheres, I put down it's a Chinese character, people. This is the red color. So if you look at the coastal ocean, it's right in the intersect between atmosphere, lithosphere, hydrosphere, and the biosphere. So it's a coastal ocean is a very special regime featuring ocean, sea, land, atmosphere interaction with very complex interfaces, and abundant natural resources are concentrated in the coastal ocean, and with very fragile ecological environment. Of course, very intensified human activity. I show you quite a few examples later on. If you look at the coastal ocean in terms of surface area, it's only represents 7% of the global ocean. But if you look at the main, the reservoir biodiversity, species abundance, about 97% of the species abundance is concentrated in coastal ocean. And it produced 25% of primary productivity of fish catch is about 90%. And again, the carbon sink, although it occupies 7% of global ocean surface area, the carbon sink percentage is 20%. And if you look at the organic matter, it represents 80% of the organic carbon and the production, and the blue carbon is about 50%. And the crude oil production about 30% of the global production is concentrated, is from the coastal ocean. So we see this associated with the population growth, and in particular, I will emphasize some of the fertilizer consumption on the land and how this leaking is coastal ocean. Those human activity put a tremendous amount of the pressure on the coastal ocean. I'll just give you some of the examples. So we call it the human ocean interface at the coastal ocean is very extremely dynamic. And you see here on the left animation, you see the different spheres concentrating again on the coastal ocean. And you see this light concentrated on the coastal ocean during the, in this regime. If we look at this, look back the past 50 years of, I would safely say that the coastal ocean is the main engine of world economic development, in particular in China. So if we look back to all these coastal area, within 60 kilometers of the coastline, for example, 50% of the population and 70% of the megacity are here. And they produce over a little bit, around the 50% of the global domestic production. And if you look at the East Asia coastal zone, and 70% of the population is resides in this coastal line. And on the right panel, you see this GDP growth during the last 40 and 50 years. And again, you see this as a main engine of the world economy, in particular Asia and China. And just give you one example, how the coastline has been modified. And in China, as an example, for now, actually more than 60% of the coastal line is artificial. And it's called the second Great Wall, if you want. Of course, you can imagine how dramatically those artificial coastline can change the coastal ecosystem and the habitats of this of the coastal in China. Another focus, as I said, is the fertilizer consumption on the land, because related to all this agriculture activity. I'm showing this fertilizer consumption around the world. You see these different lines from the regions. For example, this is West and Central Europe. And you see this dramatic increase in the 60 and the 70. Then it's getting to slightly draw down. But if you look at the red line, in the East Asia, the fertilizer consumption is dramatically increased until actually very recently. So you see this at the peak area. I will show you how the response of this in the coastal ecosystem to this fertilizer usage. So this causes, the fertilizer issue is the primary cause causing the eutrophication in coastal estuary zone. And it's a chain reaction for the hypoxia formation and linking to the oceanification. I would claim this is truly a global environmental issue. You see all over the coastal line and the ocean, the hypoxia, and hypoxia is linking to oceanification. Just one example, in the Baltic Sea, it's the largest hypoxia region in the world. If you look at the surface coverage of the hypoxia in the Baltic Sea, it's over 60,000 square kilometers. So it's a huge area if you want. And if you look at this linkage with the fertilization in the land, and then you have the nitrogen and the phosphorus loading, it's quite closely tied together until the 80s and the 90s. But it remains a big question. Again, the nitrogen factor started low decline starting in the 90s. But if you look at the bottom, the panel, the hypoxia area in terms of surface area is still growing. So this is I want to say it's a very complex issue to resolve, explain the causing and the response and the causality, in particular in the very quantitative way. So this is another example, the East China Sea of the Changjiang Estuary of the Shanghai area. Again, you see a very large hypoxia in the pink area. And if you look back the history, it started to build up in the late 90s and then peaks recently in the 26th. The surface area of the hypoxia reached to 22,000 square kilometers. So it's become one of the largest hypoxia seasonal in the world. Another very well-known hypoxia area is the Gulf of Mexico of the Mississippi. And it stayed there quite during the last 20 or 30 years. And the surface area is quite large as well. It's around 20,000 square kilometers. So I don't want to give you more examples, but if you look at around the world, and it's the trend and intensity of this hypoxia, it's quite closely linked to fertilizer usage in the watershed upstream. So you look at Europe and America, and now you see the East Asia area. It's quite it's an emerging hypoxia area related to the eutrophication. Those human activity along the coastline, the coast sea, actually are amplified by the global change. I'm showing all these global scale climate change symptoms as ocean warming, as I explained, the oxygenation, that will change the EH. That means the potential of the oxidation potential. And oceanification, that pH is a determinant of the ocean chemistry. It changed everything, including the ocean chemistry and the physiology of the many organisms. And of course, the extreme weather, sea ice melting will impacting the sea levels rise. So this global scale climate change symptom is associated with the human activity around the coast in terms of region. So the big question actually we are asking for the whole community, the ocean and climate community, if we are reaching the tipping point. That means pushing of the ocean past the point of return, no return. And you can see in terms of regional and the ecosystem, a different ecosystem, of course, it's a hard, grand challenge in terms of science and in terms of prediction. So that was the ocean and the ocean health. I just give you a very brief introduction about what's going on and the status of the ocean health. That comes up the decade of ocean science for sustainable development. And there's two motivations. One is there is urgent needs to reverse the cycle of decline in ocean health I just explained to you, and create improved conditions for the sustainable development of the ocean, seas, and the coast. And another motivation at the UN level is, of course, the global ocean science capacity unevenly distributed. You can see actually from the publication abundance from these different regions. So that's one of the reasons the Ocean Decade will enable action at all levels, all regions, and help define pathways for sustainable development. I'm just trying to quote in this Peter Thompson as a UN Special Envoy for the Ocean. Ocean science supported by the capacity development is essential not only to inform SDGs, that's Sustainable Development Goals, 14, but also other SDGs that have an ocean dimension. And the core objective of the Ocean Decade is to improve the scientific knowledge through capacity development in regions and the groups that are present limited in capacity and the capability, and then transform the scientific knowledge into solution to solve the real societal problems. Sumiani has actually already explained that's the program on December 5th, 4 years ago. And decade, we often say this is once in a lifetime. I don't think every one of us can live more than 100 years. So this is the largest the UN level program at the global level. And this decade will provide a very common framework to ensure that ocean science can fully support countries' action to sustainable manage the ocean, and more particularly to achieve the 2030 agenda for SDG. All right, and deliver science for future. For we want to study and provide data on the global marine environment, encourage new partnership. I will emphasize the importance of new partnership in the ocean-based solution. And of course, this is a new opportunity for ocean business and the business operation, conservation, and management. So this is kind of a vision, goals, and outcome. We all know that essentially we try to reverse the ocean health decline, and through interdisciplinary research, taking a very proactive way of doing ocean science and transform the ocean science, we need to protect, conserve the ocean, and better use the ocean. So in short, it's the ocean we want for the ocean science we need for the ocean we want. The goal is central to Ocean Decade is the notion of the transformation. And there are 7 outcomes of this UN Decade program, include a clean ocean, a healthy and resilient ocean, a safe ocean, a predictable ocean, a sustainably harvest and productive ocean, a transparent ocean, an inspiring, engaging ocean. This is a to summarize what's the UN Decade of Ocean Science. Again, the vision is, as I said, the science we need for the ocean we want. I put the Chinese translation here for those who understand the Chinese, called the 科学知识，海洋可期. That means you have to make the science very solid, down to the earth, to solve, understand the ocean, then to transform the ocean science into solution for sustainable development, and then also connected the people and the ocean. That's what kind of a brief discussion of the decade program. Now I just give you some information and a source how we want to articulate the coastal SOS program. Again, this is the coastal zone. Coastal SOS stands for coastal zone and intensify human activity and change climate. And again, this a dual stressor emphasized here. And then the integration between science, management, and society. And I show you all these keywords of this program in terms of science, how we want to tackle the eutrophication, hypoxia, pollution, and oceanification. The overview of this program, as I actually explained a little bit at the beginning of my talk, is the co-design between different sectors and the deliver of doing collaborative research on coastal SS, primary eutrophication, HAB, harmful algal blooms, hypoxia, and oceanification, and the linking natural and the social science to deliver this advanced knowledge, data, tech knowledge, novel partnership, and finally, decision-making toolbox. This is showing you the partnership. And we have 10 academic institutions get involved in this proposal, 6 industrial enterprises, 3 foundations, and 5 non-governmental and intergovernmental organizations. Somebody will check the chatting box. Can you check in the chat box so I can check if there is communication on that? This is the details about this academic institution, including Xiamen University, Second Institute of Ministry of Natural Resources, Tsinghua University, Hong Kong University of Science and Technology, University of Hong Kong, City University of Hong Kong, Department of Marine and Coastal Resources in Thailand, University of Malaya, and this is the host of this webinar, and University of Malaysia, Terengganu, and the Xiamen University of Malaysia. In terms of foundation, we have this China Oceanic Development Foundation, Paradise International Foundation, and initialized by Jack Ma, if you want, Swine Group Charitable Trust, and the intergovernmental organization including PAMC, you are all very familiar, and IOES Westpac, and we have 6 enterprises, including CP Group, a very big global tycoon headquarters based in Thailand, but this one is involved CP China. Shanghai Zhenghua Heavy Industry is one of the top 500 enterprise, also ocean users. And the Liantai Group Limited is essentially the marine fishery, a very big company. And the Zhongtian Technology Marine System, China Navigation based in Singapore, Jeffy Group based in Malaysia, and some non-governmental organizations, including Surface Ocean Lower Atmosphere Study as an international program. And I'm serving one of the co-chair of this program. World Resource Institute Beijing and the Worldwide Fund for Nature, etc. I don't want to get into detail. This academic and the strengths of these 10 institutions, and this foundation enterprise, and the non-governmental organization again, the WWF and the SOLAS. The region of coastal SOS is on the East Asia Seas. And there's a big area here, if you want, cover the 7 million square kilometers. And some of the features including the big river, the largest world river, include the Yangtze River and the Mekong River discharge into this East Asia Seas. And this region nourishes 20% of the world population, and a main region of seafood production, and the world's largest expansive coral reef, mangrove, seagrass. If you want, this is the triangle area. It's the highest diversity area in the world. You are all very familiar. This program picked up 6 model coast systems. We try to look into these 6 models and do comparative studies and transform the ocean knowledge in the industry practice and the policy making. So these 6 models, including Pearl River, Gulf Thailand, Johor Strait of Malaysia, in particular familiar, Yangtze River, Changjiang Estuary, Minjiang in Fujian Province, and the Xiamen Sea Area. I don't think I have time to running through all the detail of these model systems, but you are all very familiar with the Changjiang area. It's the largest world river estuary in the world, and concentrated a large portion of the Chinese population, and it's a viable economic zone in China, Yangtze Delta area. The main issue of this Yangtze River, including eutrophication associated with fertilizers consumption in the watershed, nutrient concentration loading increased during the last 4 decades, and we started to see the reptile HABs starting from 90s peak in the new century, and we're uncertain the trend about hypoxia peaks a very large area. And the main issue is, of course, how we can quantify the causality between pressure and the response in the in this complex system. I would also like to point out this region is also a very dynamic region, not only at the land-ocean interaction, but open ocean coastal interaction, featured by the crucial intrusion and anthropogenic atmosphere deposition, very high deposition amounts under climate change scenario. The second system is the Great Bay Area, the Pearl River estuary. Again, very similarly, and we have experienced fertilization, consumption, nutrient loading increase, red tide, and hypoxia. And of course, you know this Shenzhen, Hong Kong, Macau. It's a very, one of the most developed region and the highest production area in the world. And this area is also featured by coupled eutrophication, hypoxia, ocean acidification issues. The third model is the Minjiang River. Min actually means Fujian. Minjiang estuary is area. It's a small, relatively small river, ranking the 7th largest in China. It's located in the east coast of China. And one of the features is in addition to the eutrophication problem, is the strong agricultural stress. We just launched a large program, large-scale environmental friendly offshore agriculture platform scheme. This is sponsored by Shanghai Zhenhua Heavy Industry. So we'll see, on top of this environmental issue of eutrophication hypoxia, we'll see the large-scale ocean uses manifested by the aquacultures. We call the 100. This type of system will be implemented in this region. So on top of the eutrophication, the heavy agriculture is one of the main issues to be tackled in this region. Then the Xiamen Bay area, and I'm sure some of you are familiar with the Xiamen area. Is Xiamen, the coastal sustainable management system has been practicing in Xiamen area for quite some long time, back into this in 1994. So this region is a model system for best practice of the ocean science linking to the management policy and eventually the industry sector. Hopefully this can be a good model. And the Gulf Talent and then the Joe Street, I don't want to get into details, but this is emerging, I call it emerging system. You start to see the problems and the issues related to eutrophication and the coastal anthropogenic activity, shipping lines, stuff like that. So you start to see the eutrophication red tide in particular, and hypoxia, we started to see in the Up Gulf Thailand, for example. One of my students has been working on that, and many colleagues in Thailand has been notified this kind of issues. So those are the 6 model systems we are going to tackle. If you put together, you see a very common, some of the common issues: fertilizer consumption in the watershed. You see the nutrient concentration in the river and the estuaries. And then you see the ecosystem response, both in terms of red tide, hypoxia, and the ecosystem, for example, in the East China Sea of the Yangtze estuary, you start to see the community structure shifting from a normal condition to a condition that's characterized by small phytoplanktons and dinofractures. And I only have 2 slides in how to quantify those causality. And one is the quantification oxygen consumption I was telling you how the eutrophication drives the hypoxia. And this is one of the example we carried out in the Yangtze Changjiang estuary in the East China Sea. The result is that eutrophication induced organic matter is almost exclusively the driver for the hypoxia in the Yangtze Changjiang area. And this has a similarity in other systems like Chesapeake Bay or Mississippi River in the Gulf of Mexico, although it's slightly different. The percentage of the eutrophication-driven hypoxia is slightly different. So the research we're trying to tackling is, again, the dual stressors from the climate change and the pollution related with the central by the economic development and societal development. We're looking at the carbon footprint that's related to oceanification and the dual stressor of this climate and anthropogenic activity. And the second chain research is nutrient footprint and linking to this harmful algal bloom. So this is again the linking the ecosystem resilience and the societal sustainability. We're trying to build the data modeling system, eventually digital twin ocean. This is a very novel system. I will explain a little bit in a minute. So the key question we're trying to of the coastal SOS try to address are what are the key physical, biogeochemical, and the socio-economic process governing the dynamic consequence of the coastal ocean eutrophication and the climate change in river, shelf, estuary shelf system. In short, it's the RES, and how are they coupled, interacted. So we're doing 4 major actions. One is assessment and attribution. Attribute the main ecological consequence to these drivers. And we'll do diagnosis and attribution for, I have to explain a little bit for how we do the assessment. So assess what are the historical key environmental drivers and the management policy that have led to the current status of the different model coastal system during the past 50 years, I'm sorry. And then diagnosis of attribution, how that's the mechanistic studies, the key process, including the physical, biogeochemical, and socioeconomic process. And then we'll do the model simulation and the prediction for the future in next 30 years. What are future change trends of the coastal systems in responding to climate change and the regional socio-economic development for the next 30 years? How will this change cross feedback to the socio-economic system? I'm kind of running out of time. The objective of the coastal SOS formulate a novel. Again, I was explaining how we want to co-design the framework, the proposal, the program, and the co-research and the co-delivering. So one of the first objectives is formulate a novel cross-sectoral partnership among academia, industrial, non-governmental, intergovernmental organization, governmental sector with optimal inclusivity and information flow to enhance their integration and capacity in co-design, co-implementation towards sustainable use of the coastal ocean. And to generate comprehensive knowledge of coastal ecosystem and their human dimension, pressurized by intensified human activity and the climate change through scientific exploration to study ocean warming, pollution, eutrophication, HAB, hypoxia, acidification to facilitate prediction of coastal ecosystem change. Empower effective ocean governance via integrated ocean management, encompassing holistic, integrated, knowledge-based, ecosystem-based, and solution-oriented approach to ensure sustainability on coastal ecosystem. I want to skip a little bit. The approach we're trying to take is including, again, I was showing this diagnosis, attribution, modeling, solution, through chain research, cross-coupled analyze with the platform, supporting platform integrate modeling, observation, and geospatial intelligence, eventually the digital twin ocean system. Multi-dimensional observation, including satellite image. I just want to share you the good news. We just, Xiamen University launched a high-sea small satellite that is able to see very high-resolution coastal lines. And model development, we have quite an enriched experience in model development. And the digital twin ocean actually is an innovative platform for digital transformation to meet demands of the coming era of the rapid dynamic transforming ocean observation, human society, real smart society. So essentially including data collection through observation, model development, and the digital twin technology to mimic the real ocean. So you can do all kinds of the arrange of the planning and observation management, etc. I think it is obvious a contribution of this coastal SOS to this SDG 13 climate action, life below the water, and the new partnership for the goals. And I think this coastal S is fully share the vision with the decade program, the science we need for the ocean we want, taking a very proactive way of doing science and transforming the science into solution. I think it's hopefully we can contribute to that outcome. One, and the cutting prediction, model, sustainability, productivity, and for integration between ecosystem and human dimension. That's the essential component for build up of the human ocean harmony. That's pretty much the coastal SOS program introduction. A couple of slides about perspective. I'm showing you the dramatic image here, starting from 1937 with the population about 2.3 billion, and atmosphere CO2 concentration was 280, and the remaining wildness on the land was 66. Merely less than 100 years later, in 2020, the world population is about 7 billion, 8 billion, and the air CO2 concentration is more than 400. And the remaining wildness on the land is 35%. Only about half that in 1937. So we really need to learn the lesson. We practiced our development on the land and then try to learn the lesson for the ocean usage, because it's quite clear, the ocean is going to be used. The ocean space, ocean resource is going to be used by the human development. But we really ought to learn the lesson from the past 100 years of practice on the land. We also have opportunities because ocean science being advanced in the revolutionary way. We can start to look at the ocean, the global ocean and the regional ocean, almost a real-time time scales. And we are just transformed into this, the fourth industrial revolution with new technology, sorry, that's provided the tremendous opportunity for take advantage this ocean technology and applying this new technology into ocean. And we have this UN Decade program, and this is communication. I think these the phrase I like very much, the ocean we need for the future we want. no one will be left behind. The science we need for ocean we want. What we can do together, we cannot do separately. That's exactly this UN decade's call for oceans, decade of ocean science for the sustainable development. I'm trying to finish this my talk with the last slides. It's everyone's decade, and I hope and the large community in Malaysia can get involved and contribute together with us. And I also look forward to collaborate using the Coastal SOS as a platform to every one of you. Again, thank you very much for providing this opportunity for me to share with these ideas. Thank you.
Thank you so much, Prof. Minhan. What a wonderful and comprehensive presentation. I'm sure the audience was very fixated to hearing the comprehensive knowledge and info regarding the presentation and also the project that you propose to do. I think it's a very important, novel study that needs to be done, especially in supporting the UN Ocean Decade. So, ladies and gentlemen, we've heard Prof. Minhan Dai spoke almost more than 45 minutes on Coastal SOS, Coastal Zone under Intensifying Human Activities and Changing Climate, and a regional program integrating science and also management and society to support ocean sustainability. I think it's a very comprehensive talk, and I'm sure the audience amongst them have got a lot of interest, and we can actually foresee that, especially your last slide, yeah, this everyone's ocean decade, each and every one of us can play our role, yeah, to support this very important subject of sustainability for oceans. As you know, it holds a treasure trove of biodiversity and also resources for mankind. All right, thank you for that. And now we'll come to the Q&A session. There are quite a number of questions at the Q&A chat box. Okay, from Minhan, there's some questions here. I'll read out to you.
Okay.
Okay, the first question is actually from a teacher. We have a comprehensive, holistic audience today, and I'm very pleased that we have a group of teachers from schools, yeah, who are interested and who are attending the talk. And it's coming from teacher or Cikgu Zila. She asks, how does the human pressure give rise to the effects that you have mentioned in terms of ocean effects? Would you like to answer that?
Yeah, so there's a variety of the human activity put the pressure on this marine ecosystem. I give you many examples on the fertilizer usage. That's the agriculture, the essential fertilizer for usage for the agriculture production. So that's the overuse of the fertilizer caused the overloaded nutrient concentration in rivers and transport into the coastal system, causing the eutrophication. That's the massive production of the algal bloom, for example, and causing this, then the consumption of the oxygen during the degradation of this biomass. When this biomass sink into the coastal, the ocean bottom, that's caused the oxygen consumption and eventually into the hypoxia. And the secondly, the human has changed the coastline and changed the habitat. So that's a variety of the ways pathway. The complexity is that's one of the problem we are trying to tackle, how we can quantify this human activity pressure and onto this coastal ecosystem. So by using eventually the numerical model, so eventually we can predict the future change and then put a better policy. We can manage this human activity then in a sustainable way. That's exactly the goal of the UN decade. I hope that's partially answer your question.
Yeah, okay. Thank you so much, Prof. Minhan. Cikgu Zila and her colleagues, I hope that, if you have any further queries, you can always contact us at the Institute of Ocean and Earth Science. We are very happy to share whatever knowledge or info that you'd like to deliberate on further. The second question is coming from Dr. Wicha. Prof. Dai, can you please elaborate on the state of ocean acidification in your study area, especially the tropical waters, and how will acidification respond when the waters get warmer? So this is a bit scientific, but nevertheless is of interest to a lot of us.
It's a very good question. Overall, the last 200 years, the pH, ocean acidification characterized by the pH. It's a log scale of the hydrogen concentration, if you want. The oceanification, the pH had dropped down by 0.2 or 0.3 during the last 200 years since the Industrial Revolution. It's purely the penetration of atmospheric CO2 into the surface ocean. Then it dissolved and then get into the chemical equilibrium. So enhance the hydrogen concentration. That's increased the pH and the draw down the saturated state of calcium carbonate. That's the two features of the oceanification. And if you go into the coastal ocean, it's a very good question. In my area, for example, China Seas, we haven't seen a very clear trend. But if you go to the central of the South China Sea, the pH change is exactly mimic to the open ocean in the Pacific Atlantic Ocean. But if you move to the near shore, it's more complex because you have the atmospheric CO2 penetration into the ocean that causes the decline of pH, but at the same time, you have the eutrophication. Eutrophication will stimulate the productivity of biological activity. That's primary productivity, if you want. That's a counter effect of the pH decline. So we haven't seen a very clear trend during the last 50 years, how the surface pH or oceanification has changed during in the coastal area. But if you move to the west coast of the US, that's the eastern boundary current system, we see very clear pH drawdown on top of the atmospheric CO2 induced the decline, but also the eutrophication caused the hypoxia, then induced the production of hydrogen ion, then that's put together. And in the bottom of the water in the coastal around East Asia, we see the hypoxia. I have shown you many examples. That's hypoxia. That means deoxygenation, consumption of oxygen in the summer or spring. That's also what enhanced the oceanification in the bottom water. So I was talking about surface ocean, there is no clear trend, but as far as the bottom water, wherever you see the hypoxic water, there's a clear trend, enhancement of this hypoxia that causing the enhanced oceanification in this bottom water. This is a combined joint effect of atmosphere CO2 penetration causing oceanification, and also the land-induced eutrophication induced oceanification.
Yeah, okay. That's a very comprehensive answer.
One way,
yes.
get warmer.
Yep.
It's also a very good question. In the surface, warming can't affect the oceanification because pH is determined. So that's a good news, okay? To put a very simple way.
Yeah. Okay, Prof, I have to move on to the next question. You seem to have been getting a lot of questions, a lot of interest in your talk. The next question comes from Mr. Robin Robertson. his question is, there is a scarcity of observational data for the Southeast Asia region, especially the Gulf of Thailand. Are there any plans to increase the observational database with real-time observations available on the web, such as ocean temperature, dissolved oxygen, salinity, ocean color, chlorophyll, etc., such as would be provided by gliders or real-time moorings? Yeah.
Thank you, Robin, for the question. And it's a tough question, but that's one of the motivation I try to initialize this coastal SOS program. And through capacity enhancement in the East Asia region, I think observation is essential. No data, no science. No science, no sustainability. That's quite clear.
Yeah.
So we have to build up the capacity that enable us to observe the ocean, collect the reliable data in real time. So through this coastal SOS, I had some very brief introduction so far with the partners. So we're trying to standardize the observation system essential for this region, and try to help and get these industry sectors and the foundation sector try to help build raise the funding resources and build up this observation system. That's essential, because so sparse of data, so the knowledge of the East Asia is very limited though. So that's the first step of the coastal SOS. Then I think there is many things we can transform and transfer expertise during this model system. We hope we can standardize the observation system, data quality protocol, then such that we can get the reliable data. Then we'll try to build up this modeling simulation system for the model system. Again, there's a lot of the experience and the cross-reference we can learn from each other to simulation. Then we get the data plus model, and the data is never enough, and the modeling is never ideal. So we have to integrate the model and the data. That means observation. Then eventually we can get into the digital twin ocean system that can help to fully integrate everything together. The space, the ecosystem, the observation data model, data simulation together. So it's a long way to go, but we ought to get started and build up the observation system of essence to start the research, understand the regional local system for a better practice, CUs, and the policy. Thank you again.
Yeah, I think that's very important. Data monitoring is so important, because what you can't measure, you can't manage. So I think this is the starting point. There's always a starting point somewhere.
Exactly.
Yeah.
Exactly.
And we hope your project SOS would actually make the bedrock of that foundation of future planning. We have actually two more questions. I hope you can answer that quickly because of the time limitation. One is from Dr. Kish from UM. Why is the coastal SOS only focusing on Johor Straits specifically and not Straits of Malacca, for example? A quick answer, Prof?
We pick up the system typically has these eutrophication issues. So that's one of the reasons. To simply answer that question. Yeah. And we can expand from the 6 model system, we can expand the study area, because but we welcome collaboration. I think this is the starting point.
Yeah, we look forward actually. Yeah. All of us and the multi-stakeholders involved in the SOS, I'm sure we can contribute. And the next question quickly from Ambun Dindang. He asked, one of the slides showed that CO2 increases to 415 ppm and the wilderness reduces to 35% in 2020. What is your prediction for this in the next 20 or 30 years in the future? This is us worrying about the future.
It's difficult, but to cut my answer short, there's 2 aspects. One is the Paris Agreement. So we can predict with the very aggressive and the proactive way of the cut emission and enhance the carbon dioxide removal, carbon sink, if you want, both into the land and the ocean. That's exactly what the Paris Agreement wants to achieve for the 2050, and China just declared peak the carbon emission in 2030 and then carbon neutrality in 2060. So you can predict that based on this emission scenario in 20 or 30 years, the 40 years, 30 years in 2030. It's hard, very hard to predict the wideness on the land because it's all depending on the sustainable practice during the next 20 or 30 years. I, of course, sincerely hope the wideness can be maintained, keep the 35% of wideness on the land, and equally important, I show this. I was showing this a slide. Try to caution people to learn the lesson from our practice on the land, and we just started to use the ocean space and the resources, and in a dramatic way, unsustainable way. That's one of the reasons we try to understand the ocean. Try to build up the partnership between academia, industry, and the governmental sector. So you have the ocean policy to sustainably use the ocean, manage the ocean. Thank you. It's a good question. Yeah.
Yeah. I know there's a lot of things that people want to know more. Last question, a quick one also from Mr. Wong from TMSI. Johor Straits in southern Malaysia is relatively narrow and more enclosed than other estuary systems like Changjiang River, but it is connected to many rivers. What will be the challenges in studying hypoxia and eutrophication in this type of system?
Yeah, it's a very good question. I was saying eutrophication river import system. Johor Strait, exactly, it's a very narrow between Malaysia and Singapore, but this is featured very intensified urbanization and human activity, and we start to see the eutrophication harmful algal bloom. So there is similarity and the difference from other systems, but it's a good system as well.
Yeah. All right. Thank you so much. Thank you so much for the very interesting talk, very comprehensive, in-depth, knowledge for the audience regarding not only your program or your project under the UN Decade of Ocean Science, but overall in terms of the importance of ocean science and also the importance of conservation of our oceanic resources. And your talk actually has stirred a lot of interest, especially to us academicians, and also other stakeholders to formulate the cross-sectorial partnership, very important, and generate comprehensive knowledge of coastal ecosystems and hopefully to empower effective ocean governance to the authorities and our governments. So thank you so much, Prof. Minhan, for spending.
Thank you. Thank you again. It was a great honor.
Nice meeting you again, and have a nice.
Unfortunately, I have to leave.
Bye. Yeah, I know you have to leave. Okay, see you around sometime.
Yeah. For in person somewhere.
Bye-bye. Thank you so much. Thank you so much. Bye.
Okay.
Okay.
Bye-bye. Bye-bye, everyone. Yeah.
Bye-bye.
Thank you so much, everyone, for still being in our webinar. It has been a very, very interesting talk and has created and stirred a lot of interest because it's all very relevant, very related to all of us. And now you'll hear more interesting topic and presentation from none other than our second speaker, Prof. Dato Azizan, who is a very famous professor in the field of meteorology in the Department of Geography, Faculty of Arts and Social Science in UM. He's also the director of the National Antarctic Research Center and deputy director of the Institute of Ocean at the same time previously. He's currently one of the vice president of the Scientific Committee on Antarctic Research and is on the editorial board of Polar Journal. He's also the Malaysian coordinator of an European Union research project, SHIVA, which is stratospheric ozone, halogen impacts in a varying atmosphere, and also a steering committee member of Asia Pacific Rim University World Institute Pacific Rim Cities Climate Change Mitigation and Adaptation Strategies, APRU-CIMAS, and is a member of the International Advisory Committee of Asian Network of Climate Change and Technology. And his biodata goes on and on. I'm sure you can Google and you can look at his comprehensive achievement. But I think more importantly is we want to hear to his talk today, very important, and bringing us closer back to home and also at the region with his talk entitled Climate Change in South China Sea. So Dato Azizan, the floor is yours. Welcome.
Thank you very much. Let's see. Can you hear me?
Yes, all good.
Okay, that's good. All right. Well, my talk will be challenges of climate change in the maritime continent, and especially looking at the South China Sea. And every time when I talk about the South China Sea, I'll put this particular image. It shows how complex is the South China Sea. It's a big hotspot. But when you sail on the South China Sea, this is how it looks. It's very calm. And if you look underneath, there is IOES, which is scientific. There is NARC, which is Antarctic and the polar region. And I'm also from the Department of Geography. And when you study the South China Sea, every part of where I'm joined comes in, and that shows the extent of the South China Sea influence and the extent of the system that influences the South China Sea is very much global in nature. So where do I start? And in my lecture, basically, especially for those not familiar with global warming, I can talk a bit about global warming as the issue. And then the next one is just to give you a flavor of the research in the South China Sea, some of it undertaken by my group and some of it undertaken by others. And as you can see, even Xiamen has their own interests. And coming from a meteorologist, I take it from first weather and climate, and then the interconnectivity of what's happening in the South China Sea, some of this climate variability, like MCO, MJO, ENSO, La Nina, and then there is some future prediction of the maritime continent and the South China Sea. And then I also will be talking a bit of the non-physical aspect of the South China Sea, which is related to the marine resources. Okay, first thing is climate variability is not new. What I'm presenting to you is the red in color is the temperature variation. Our global average climate temperature is 15 degrees, and it oscillates from this average global, it's not Malaysian temperature. So it's based around 15 degrees. But what I'm trying to show is that if, let's say, the average global temperature goes up to 2 degrees, we are what you call in the interglacial age. And if the global average temperature goes down by about 4 or 6 degrees, then we are interglacial. So when you look at this is time, this is present, this is far back, and this is taken from the Vostok ice core in the Antarctic. So now you're seeing where the Antarctic comes in, because some of the best ice core to study climate variability in the past comes from the Antarctic. And in the ice core, you can look at the trapped carbon dioxide concentration, you can look at the trapped methane, you can look at the oxygen isotope, which is an indication of precipitation. Right? And then you can see at the bottommost is the sun cycle. So basically the one that forced the climate change is the sun. And the sun goes through a period where it's a bit far away, and then the earth cools down, and then it's a bit nearer and the earth warms up. But there's also a very high correlation between temperature and carbon dioxide. And this is what you call the greenhouse effect. So whenever you see the carbon dioxide goes up, you can see the temperature goes up. And then when the carbon dioxide goes down, the temperature goes down. And this is important in the sense when you look at this graph, what you see is that the Earth actually likes to be cool, because you can see there's, is cold for about nearly 100,000 years, and we just came out from the last ice age about 40,000 years ago. Okay. Now, what was Malaysia like 40,000 years ago? This is what you call the Sunda land. And that's the reason why you have Asian elephants all over the place except for, in Sumatra, because last time this used to be land. And so this peninsula, this Sumatra, and this Borneo. And it's only now, when the ice age recede, that the Sunda platform, what you call the Sunda platform, was inundated. And what I want to show to you is that, so 40,000 years ago, South Asia is a very different place. It even has savanna. And so you can see our great-great-grandfather hunting, not elephants, but what you call, there's another pachyderm, which is not elephant, but and they have sort of mastodon, and also UM has found some mastodon teeth up in Malaysia. So this was a picture 4,000 years ago, and what I'm trying to show to you is that among the place that is most impacted by the sea level rise was our place. That was 40,000 years ago. We lost so much land 40,000 years ago. So in what I'm trying to say is that Malaysia, or the Southeast Asian region, is one of the areas that in a way suffered from global warming, but that is a natural global warming when we got inundated. And we've got the benefit also, because the fact that you can have oil all over the place in the South China Sea is also related to the fact that you have entrapment of all the what you call as the biomass starts to what you call change and erode, then you have your oil. So we benefit from it. So this is the paleobiology of the Sunda, and you can see that the famous Wallace line being drawn that divide the Asian biology with the Austro-Asian biology. And that's the famous Wallace line. So we are also part of the global biodiversity change that we have here. So what is it? Now what you have in our situation is, since the 19th century, you have an increase of carbon dioxide. And the scenario, if we keep the business as usual, which is about we're expecting to have about 600 to 800 part per million of CO2, then the expected warming is going to be 4 degrees. And that is scenario A2, right? This is a red scenario. If we manage to do a bit of what you call mitigation, we may end up 3 degrees warmer. If we trying to hope for is this one, the blue one, which is 1.5. So this is what you call the Paris Agreement. And if you are able to cut down totally, then you go for the purple one, which is there, and what you can see is that even if you have zero emission, you're still going to have some form of warming. So the warming is already locked in. Now the regional response to warming is a bit funny, you know, it's not just every place get warm, but some places where you can see the bluish color, okay, oops, sorry. Here, they do get colder. So some places are warmer, some places will get colder, but the more important thing is that the greatest warming is in the polar region. One is in the Arctic and the other is here in the peninsular area of the Antarctic. So those are the areas in which you will have the most warming. And it has some significance, as you can see, people are predicting that in summer, there may not be sea ice in the Arctic anymore. And that has implication in transport, has many, many implications in terms of geostrategic, because, you know, we have Russia basically sitting on top, and so it may be a boom to the people in the Siberian area. The other aspect of global warming is the sea level rise, and this is a second graph, and what you can see is that by slowly the sea level is rising, and the sea level is rising about 3.2 mm per year, but this is an underestimate because there are certain processes, especially in the West Antarctic region, which I will show you later, that may increase the rate of average sea level. Okay, so being a meteorologist, what are the drivers of weather and climate? You know, why are the things that varies the climate of the maritime continent? The first thing in which what I'm trying to show is that some of it cannot be modeled properly yet. So you have to take global model with a piece, with a what you call a spoon of salt, or maybe a bucket full of salt, because there are quite a number of things that's happening around our region that is not being able to be, what you call, the model has not been able to catch some of the climate variability. And that was why we have the year of the maritime continent, where lots of observation were being undertaken around our region to understand how our region will behave with global warming. So the variable is the constant one, that means the sun. And of course, our orography, the pattern of the South China Sea itself. While the variable one is the monsoon, we have the northeast monsoon and the southwest monsoon, which talks about the wind. Northeast monsoon, the wind is from the north and northeast, while the southwest monsoon, the wind is more from the south to the southwest. And then the other one, that is about 6 months. The other one is what we call intra-seasonal, is the MJO, Madden Julian Oscillation. That's about a month, 30 months. And so you have period of dry period and then period of high precipitation. And this control the intensity of the rainfall over the region. So when they coincide, you have a lot more rain. You know, like they think that some of the more extreme flooding is because of the interaction between the monsoon and the MJO. On the longer term, we have the 2 or 3 year cycle, which is the Enso La Nina, and then we have the 4 is the 10-year cycle, which is the Pacific Decadal Oscillation. And then there's also link, as I said, between the high latitudes and the tropics, between the polar region and the tropics. And then, of course, there's a variability, the impact on primary productivity and also on fish landings. So this is diurnal. So you can see from 8 o'clock to in the morning, and then by afternoon, you can see most of the thing has moved so it's offshore and then it goes onshore a bit, by 6, and then after that it goes back to offshore. And the whole system, even if you have the monsoon or you have the very what you call extreme cloud clusters that cause very heavy rain in our region, it oscillates following the sun. So most of the time in the morning, you can see that the cloud is over offshore, and then by noontime, it starts to come inland. And no matter what sort of system, this is a very strong influence. This cannot be modeled at the moment. Models cannot do it. And we have problems in trying to predict where the cloud cluster is. So don't blame the Met Service too much. Is the Met Service forecast of thunderstorm is not that right, not that accurate. It's because the model, the best model in the world, still cannot get the dynamical cycle properly. And of course, the other one is the orography. This is some work done by Fadil, in which he removed or flattened Sumatra, and then as you can see from the bottom one, it shows how it changes in terms of the rainfall. So this is what Fadil did for his PhD, just removing the orography of Sumatra. So Sumatra is an important part in terms of even the MGO. And so you need to get the right orography for you to do the prediction. And one thing about scales, when you want to get Sumatra, your resolution for your model gets higher. That means maybe you need to do a 10-kilometer grid, and that's a lot of computer time. But when you look at global model is about 50 kilometer or maybe 25 kilometer grid, 25 by 25 kilometer. So this will then flatten the mountains, and the impact of Sumatra might not be shown properly. So this is one of the problem of modeling. So this is the northeast monsoon. What you have is wind is driven by pressure. So you have high pressure over in the north, low pressure or the trough over in our region, and then you have the northeast monsoon coming down from the high pressure region. Conversely, when you have high pressure over Australia, you have still low pressure over our region here, and then you have the southwest monsoon. And so this ding dong occurs. This is June, July, August, and this is December, January, February. So we are subjected to this movement of pressure system in which we get our two monsoon system, the northwest monsoon and the southwest monsoon. And it plays an important role, not only in terms of weather, but also in terms of the circulation of the South China Sea. So you can see during winter, the South China Sea flows from north of the South China Sea down to south. In summer, it flows from south to north. So one of the things that I always argue is that the north-south China Sea, which is of course very much around Hainan side, around China side, and the south of the South China Sea, which is around our side here, are interlinked. So in order for you to understand what is happening in the South China Sea, you have to know what's happening in the north as well as what is happening in the south. And I'll come back to you why that is a very important statement. So this is rainfall, and you can see the rainfall swing, in which in winter, most of the rainfall is over in Peninsula and Sumatra, while in summer, most of the rainfall is up north. And this is because of the monsoon trough or the ITCZ moving up and down every monsoon, and it then controls the rain. But when you look at intensity, the South China, the most important, this is JJF minus the summers, this winter minus summer. What you can see is that the influence of the winter is a much more stronger influence. Okay, so the net moisture transport in the South China Sea is done in winter. So I will not go deeply into this MGO, but what I'm trying to say, during the surge, which is the one that caused our flood, when there is no MGO, the surge is higher. When there is MGO, the surge is less. So MGO, in a way, dampens the surge because it's coming from the west, while the surge is coming from the east. So I won't go deeper in that. Right. So this is in winter. So you have this Siberian high, you have this intensive area of high pressure, and this is where the source of your northeast monsoon from the Siberian high. And what happened, you have outbreak from the Siberian high known as cold surges, and then when the outbreak comes, it then interact with the monsoon trough and the orography, and then you have the Borneo vortex being established. The Borneo vortex then causes this. So there is a paper that we published on the interaction of the Borneo vortex and how it interact globally with and you can see that in JGR. So basically in our research, we found that the push factor is a Siberian high. And then when you have the Siberian high, you have a surge coming over the South China Sea, and the surge increase the wind velocity over the South China Sea, and it becomes very moist because the sea warms it up. And then you have the ITCZ or the monsoon trough, and this then produce your MCS, what you call mesoscale cloud cluster that produces a lot of rain, and that's the cyclonic vortex that order the rain, and then you have sustained rainfall of more than 48 hours, and then of course you have your flooding. So the main basic question in the tropics in our region, we have thunderstorm every day. So it's not rainfall intensity, it's rainfall, what you call duration. How long does the rain continue? Because in the thunderstorm system itself, it has a switch off mechanism. Because the moment you have a downdraft, you develop a cold pool underneath your cloud, and so when you develop the cold pool underneath your cloud, then you cannot have any more convection because convection is from the heating at the bottom. And that will switch off your thunderstorm. And that's the main reason why thunderstorm normally is only about 1 hour or so, because it has its own switching off mechanism. But what the orderly system does in the cyclonic vortex is create a lot of wind at the surface, and this basically feeds more moisture into the thunderstorm system, and that's why associated with this sort of system, you will have rain that is 48 hours or so. And of course, when you have rain of that nature, you know, let's say you have 600 mm of rainfall in 2 or 3 days, you're going to have a major flooding in your hand. The other one that controls moisture is the ENSO cycle. This is a 2 to 5 year cycle. Under neutral condition as it is now, our region is a region of uplift in the air, and you have what you call the Pacific Walker circulation. So our region is a region where the air is rising, so we have rain. This is La Nina and neutral situation. But due to the change of the sea surface temperature, the El Nino, the sea surface temperature, instead of being warm over in the Western Pacific, becomes warm in the middle of the Pacific then you have what you call a La Nina, an El Nino situation. And this is basically an interaction between the ocean, which is the sea surface temperature, the thermal hairline, and the atmosphere. And this is about a 2 to 7 year what you call oscillation. And again, let me point to you, the model until now cannot yet simulate the occurrence of El Nino properly. The model has El Nino in it, but it occurs at a different time than what it should. So not to say that the model doesn't have El Nino-like situation, but when you do a back modeling, it got it wrong in terms of the timing of the El Nino, because it's very much controlled by sea surface temperature, in which the model is not able to handle that well. And this is a consequence of El Nino. It's a huge system and it impacts globally, right? So when you have El Nino, Australia is drier, we are also a bit drier, but America is wet and Africa also is wet. And when you have a La Nina situation, we are wetter, but the South America is wet, but the Amazonian is wet, right? So you have this, what you call dipole of response, wet, dry, dry, wet situation. Now back to the South China Sea. What drives the South China Sea is precipitation, runoff from the land, and the wind stress. And as a tropical sea, most tropical sea are like desert, because of thermocline. But the South China Sea is not, because it receives quite a lot of nutrient, is in a way quite shallow, and so it's a bit more easily well mixed, and it is one of the most productive tropical sea. And the thing is, because it's shallow, it is influenced by the southwest monsoon and the winter monsoon, as I shown earlier, where the current goes up and down from the north of the South China Sea during the winter to from the south of the South China Sea towards the north in the summer. Now, one of the proxy for ocean productivity is chlorophyll A, okay? So when you look at chlorophyll A, what you can see is that whenever the temperature is up, right, chlorophyll is down, and whenever the temperature is down, the chlorophyll is, up, the chlorophyll is down. So chlorophyll A likes cooler SST compared to warmer SST. Now, when you look at turbidity deals with is a proxy for discharge, and what you can see is that there is what I call two peak, one in the winter and one in the summer in terms of the peak, but the summer one is much bigger. And the correlation, I don't know why this one happened, the correlation between chlorophyll and sea surface temperature is better than the correlation between between turbidity. Okay, in terms of fish landing, whenever you have good chlorophyll A, you have increase of fish landing. I don't know why this is happening now, sorry. Okay, now back to my question. This is the issue. You see, there's in the north of the South China Sea, you can see huge amount of information. And I take you back to Minhan statement. No data, to support your model is junk. And so here, we don't have much data. And it's only recently, under the cooperation with FIO, that we managed to put the only working Met Ocean data in cooperation with FIO, just 100 kilometers away. And so just about here, trying to fill in the huge data gap. And it goes back to my first slide. The only country that has capacity to do all this is China. Vietnam hasn't got that capacity. Malaysia hasn't got that capacity. But because of the geopolitics, trying to get more information on the South China Sea is a very difficult maneuver for any scientist. And this is one of the challenges that we are facing. So these are model generated, and this is some of the work that I've done with my colleague Farshid Darabu on ocean dynamics. And what it shows is all the eddies, and all these eddies have function in terms of controlling not only the transport of what you call spores, the transport of the upwelling, chlorophyll A, and also fish, because fish use current and turtles also use current for their movement. So, you know, it's a very important modeling exercise. But as I said earlier, modeling without observation is junk. So we need more observation in terms of the South China Sea, especially in winter. And so this during Northeast monsoon, and you can see that during the Northeast monsoon, there's a development of a cool tongue of SST. This is in month, and then the cool tongue will starts to build up, and then it starts to retreat. So this is in November. You can see the cool tongue coming in, and then by March, you can see the cool tongue retreating. And this basically is pushed by the Northeast monsoon wind. So the question is, what happened if the prediction is that the Northeast monsoon wind is going to be weaker? Will that have an impact on this cold tongue development? And if this cold tongue is not as extensive, does this has an impact on our, what you call, on our productivity? So this is some question. Right, now you can, this is salinity and chlorophyll A concentration, but what you can see, as I said, is how am I going for time, Effendi? Effendi, how am I going for time?
Yes, you have 10 more minutes.
Okay, so I'll go quickly then. So this is primary productivity. You can see why I said the South China Sea is very fertile. Yes. So you see most of the colors are here, while the Western Pacific, they're not much of chlorophyll A. And that's why it makes the in terms of biological resources, in terms of biodiversity, the South China Sea being one of the hotspot of mega biodiversity, and also the hotspot of primary productivity. There's a lot of fish here. Right. La Nina impact on primary productivity, and so what you can see in La Nina, the Vietnamese overturning is very intense, while during ENSO, the overturning moved to the north of Borneo. So ENSO, the north of Borneo is more productive in comparison to La Nina type. Okay, I will then quite fast move. The Arctic oscillation controls the Siberian high. When the Arctic oscillation weakens, then you have cold air outbreak from the Arctic that will make the Siberian high more intense, and in fact that will then make the cold surge more intense. So we have maybe a reverse situation with what you call rapid Arctic warming and what you call the making the Arctic oscillation negative. Yeah, so it become, and that has an impact. And you can see the anomaly between the Siberian high. So when the Arctic oscillation is positive, the Siberian high is warmer. That means the cold air cannot outbreak out. But when the Arctic oscillation is negative, the Siberian high become colder because the cold air from the Arctic will then come down. So global warming could increase the intensity of the Siberian high, and that could then increase the intensity of the surge, and that might have an impact not only on rainfall but also on the wave storm surges. The storm surges can be more, and what you can see when you have higher storm surges, you have more erosion, as you can see what's happening in the East Coast. Okay, I'll skip that. So the projected sea level change is about 3 mm per year, so they produce about 3.4. But what I want to show you is the fact that if the West Antarctic ice sheet were to melt, which is West Antarctica, it will contribute a further 8 mm of sea level. So this is the uncertainty in the Antarctic that has not yet been able to model. And this is what most of the polar scientists, some of us, especially from UMT, if I'm not mistaken, is looking into this West Antarctica and the NARC, in the instability of West Antarctica. He did his PhD in Imperial, Fairuz, I think his name, but now with UMT. So the other aspect between the pole and the equator is, of course, the thermohaline circulation. And what I'm trying to show you is what you call the Pacific Western Boundary Current that is very much driven by wind stress and how it changed with ENSO. And this has an important impact on our primary productivity and on our region. And there is a big, what you call, as I said, a big question mark, because the data, let's say the flow over Karimata Strait, that is still not much observed, especially in winter. And that's one of the reasons why we are suggesting with the Chinese that we should do a cruise in winter, because most of our cruise is in summer. Now, the Antarctic has a direct influence on the monsoon. And this one reason why it's very important that we enter into this global effort is because when I was talking to my colleague in the Antarctic, most of them are more interested in what are the weather export, what are the climate export from the rest of the world to the Antarctic, because they are very passionate about the Antarctic. But it takes somebody who has monsoon experience to go in and say, look, I'm not interested to see what is happening, you know, how the Antarctic is what you call being influenced by weathers from outside the Antarctic. I want to know the other way around. How does the Antarctic influence our region? And the other way is, how does the Arctic influence our region? So we are looking for signals from the Arctic to the maritime continent. We are also looking for the signal from the Antarctic to the maritime continent. So the perspective comes in from the researcher, because the researcher is the one that controls what he wants to research. And this is what I'm trying to say. One aspect that is important, because when you look at this is a Nature paper. And one of the challenges that we have, I mean, we nearly missed one Nature paper when we did on the export from our gore. We tried to put in Nature, but we did not get publication. But what I'm trying to say, some of the work that we are undertaking are what you call global signs of significant importance. And this is the first paper published in Polar Science that basically discuss how Antarctic sea ice impact on the Indian summer monsoon. First paper, and it's contributed by our research group. Right, so this is future scenario. Most of it is going to warm up, okay? So you can see, you know, with let's say 4.5, you can see 0.5 increase in temperature. So I'm not going to go, but more importantly, most of the what you call study in the winter monsoon indicate that the winter monsoon is going to index is decreasing. So they are going for a weaker winter monsoon. So this is what the model is saying. I mean, models as a question mark. You need to investigate further. And this is sort of precipitation. Most of the precipitation is going to show that the Indonesian region is going to dry up more so, and the South China Sea is also going to dry up, and that will then have some implication on the salinity of the South China Sea. So the change in the South China Sea is very complex. It's not as simple. But what I am trying to say is that, why I say is that the one that really needs to look and really understand the local situation is us here in Malaysia, in Indonesia, in Vietnam, and also in Hainan, north of the South China Sea. So it is in our interest that we should cooperate to understand this very important region. And when I say very important, I mean really very important region, not only in the aspect of biodiversity as a refugia for corals, but also as an important hotspot on climate change itself. Thank you. I hope I've covered a bit of the flavors. Some of the research we are doing ourselves and under a high COE, and some under the Antarctic program. And so what I'm trying to say, this is research in progress, and we are very happy to have more collaborators who are interested in our work. Thank you very much.
Thank you so much, Dato Azizan. Very interesting, very comprehensive presentation, and we can see the hard work that he has put in over the years. And that's the reason why he is actually an authority in the area of oceanography, climate change, meteorological effect, and so on. And his presentation relating to the climate change in South China Sea, especially the challenges in our maritime continent and South China Sea, I think strike a chord because of the importance of our region, the hotspot, and its implication, not just to biodiversity, but also hotspots of climate change, and also I think implications towards the economy and also the well-being of the region. Okay, so there are a lot of, I'm sure, interest. And I think there are some questions for you, Dato. We know that your paper today was actually, I think, very comprehensive, also putting a lot of substance in the science behind of climate change. It's very educational, and we are very happy to note that, among our participants today, we have also the public and also school teachers, who would actually benefit a lot from the explanation and also the science behind climate change. Okay, so there's a lot of comment thanking the presenters about the fantastic, great info. There's one question from Cik Muhammad Khairul Nizam. Currently, based on the data we have, how is the effect of climate change on our coastal water productivity, especially east coast of Peninsular Malaysia? Cik Khairul is from, Mr. Khairul is from UPM. Yeah. Dato, you can answer that.
We have worked on a report on ocean account. In terms of our fish landing and fishing activities, what we found is that there is overfishing already in Malacca Strait, on the Strait of Malacca. But for bits of North Borneo and also Sarawak, and also what you call East Coast, still in a way underfished. And that's the main reason why you have foreign fishermen trying to go into our EEZ, because we are among the few, and also bits of Philippines. So in terms of our coastal water productivity, I mean, it's still there. It's not as degraded as in terms of when you look at the fish landing. The fish landing in the East Coast is still increasing, not plateauing, because once you see it plateauing, you know that you are overfishing, and that will then have an impact on the ecosystem overall. So in terms of what you call primary productivity in chlorophyll A is still, when you saw the plot that I showed, it's still quite consistently, it's not decreasing. It's still there, it's just oscillating between winter and summer when it goes up and goes down, but it doesn't show a trend of increasing or decreasing. I hope I can answer that, what you say. So that means there's no changes at the moment. But if you have a warmer SST, then from that relation, what you're going to have is that you have a decrease in primary productivity. So in terms of sensitivity to increase of temperature, the ocean actually is more sensitive in terms of primary productivity, because that's the baseline to changes in temperature in SST in comparison to the terrestrial. And I think we should focus, and this is one of the things, our area under EEZ that is in the ocean is bigger than our terrestrial land. So we are truly a maritime nation, so we should put in more effort in our understanding our ocean, not just the coast, but the whole ocean. Thank you.
Thank you, Dato. Yes, I think it goes without saying the importance of the ocean, as Malaysia being a maritime nation. If there are any other question from the participants, we have a few more minutes that we can spare. But I would like to ask a question, if you don't mind, Dato. From your studies and also the simulation of your data synthesis and analysis, how do you foresee the effect of climate change in terms of its severity and in its impact, especially to our coastal areas and the coastal community? I mean, especially in terms of, of course, there's a vast array of impacts that is anticipated. But I'm talking more of the concern of inundation of the coastal areas with sea level water rise.
Okay, because how the system interacts with changes in the sea surface temperature especially, and also the monsoon. So how the system interacts is complex. But what we have is a very nice natural, what you call variation, which is related to the ENSO. So in ENSO, the sea surface temperature goes up, contrary, because the West Pacific goes down, but because of the fact that we got more sunshine, the sea surface temperature goes up. The northeast monsoon is weaker, and this is what is predicted by the model. So you can use ENSO as a point of study, because we have a number of ENSO. So what you do, you composite all the ENSO event, and then you study how does the whole system in the in the South Asian region responds towards a change in temperature, in sea surface temperature especially. So you have a natural experiment that you can do, that you don't need to depend too much on the model, because as I said, the model has a lot of question mark to it, and it's not the best. The other one is, of course, based on that, you can also then put scenario cases, and scenario cases you can put without any what you call modeling. You can say what happened if the wave, instead of 3 meter, the wave goes to 3.2 meter. Then you can model it and see how the what you call, how does the coast impact, how does let's say how does primary productivity. So you can model that based on a scenario situation where you don't need to depend on models. The main problem is it doesn't look sexy enough when you don't do models. But what I'm trying to say, sometimes models, if there's no validation, looks very nice, but they are junk. So so you have to be innovative and clever about how you study this. Thank you.
Okay, Dato. Thank you for that. I was anticipating some answers probably about some probably estimation or postulation of, like, for example, I've read in some scientific report saying that most of our coastal city in Malaysia could actually be inundated with water with the anticipated increase in global sea water level rise and also the impending climate change effect. Okay, thank you for that very comprehensive and interesting talk.
There's too many people crying wolf sometimes, and it gets into the press. I think I come from Kedah, and they were saying that in the future Alustar will sing.
Yeah, and a few more cities. All right, me coming from Penang too, might be affected. Okay, I think we have made it very successfully. We have overshoot a little bit of our time, which I think the participants won't mind because of the interesting topics and also the interactive nature of the presentation, which actually strikes a very interesting chord to all of us. As you know, our webinar is actually a built-up program with the Ministry of KASA, yeah, Kementerian Kita and Air, which will actually culminate in the pinnacle of the national launching of UN Ocean of Decade for ocean sustainability. And I hope that all of you have actually garnered a lot of education materials and important info. And also to please join the ministry's launching tomorrow that will actually show Malaysian commitment to the importance of our contribution, yeah, to this UN Decade of Ocean Science for Sustainable Development 2021-2030. This decade play a very crucial period of our time where we have to seriously, embrace and enhance and empower ourselves at every level to ensure that we can actually portray and also contribute in our commitment and our responsibility to ensure not just environmental sustainability, but also specifically the marine ocean resources and its sustainability for our future generation. So we've had two fantastic speakers. Thank you so much, Prof. Dato Azizan, for that second talk related to climate change, yeah, and continent challenges in maritime continent and South China Sea. Earlier we had Prof. Minhan from Xiamen University, China, which spoke about the comprehensive program and the commitment from the national, international community with the multi-stakeholders on the Coastal SOS, Coastal Zone program, a regional program integrating science, management and society to support ocean sustainability. And we would like to thank our co-organizers, especially the Ministry of Environment, Water, and also, of course, our counterpart, First Institute of Oceanography, China, and us all in Institute of Ocean and Earth Science, University, Malaya. All of us have got a very important role, and we have a direct contribution through our scientific expedition, scientific exploration and scientific research that could actually support the agenda for UN Ocean for Decade Science for Sustainable Development 2021-2030. And with that, I hand over the session back to our chairperson of the program, Mr. Effendi. And lastly, I would like to thank all the participants for being very diligent in attending and also in staying until the end. Please do not leave yet, because we will actually have a record for photograph session to ensure that we put it and document it properly. And there was also some requests from our participants that wanted some e-certificate, yeah, for attending, especially to the group of teachers. Yeah, I'm very thankful for them for participating. We can arrange that. Just email to us and with your full name, and we will try to send out to you the e-certificate later on. Okay. Thank you so much. Back to you, Mr. Effendi.
Thank you, Prof. Thank you, Prof. Sumiani. And also thank you to the two panelists. They gave wonderful presentations. I think we learned a lot from them. Also, just before we end, there are some questions, and there was not, we couldn't answer because the time was limited. So please email it to us and we'll forward it to the panelists. And we will try to get some answers for you. And also about the e-certificate, yes, please email us. We'll, if you need the e-certificates, and we'll send it to you as well. The other thing is that since we are using this Zoom webinar session, I know that we cannot get all the videos coming in from the attendees, but if you could just stay on for a while, we'll just take a picture with your names on it on the video, and that will be fine. So just hang on for about another 10 seconds, so that we'll get some screen captures of your names as attendees. So again, we want to thank everyone, and hopefully we'll be running another webinar soon from Institute of Ocean and Earth Sciences, and we would be glad if you could attend the next webinar that we'll be organizing soon. So I think that's it. Thank you very much again, and all the best to you. And remember, this is the decade of the ocean. Keep our ocean safe. Thank you very much.